All right. Hi, everyone. I'm the last presentation of the day, so I hope you're all not super tired, although I'm guessing you guys are all really tired. But that's okay. So today I'm going to be talking a little bit about our software team and what we've done to make it, build it from the ground up, because this year we have over 17 people on our software team this year. Yeah. So a little bit about me. I'm a senior on the team. I've been leading the robot software team for 2 years now. And we're going to start off with the off-season, so what we do in the off-season and training. All right, so what we do with our training is, the first thing we do is just onboarding. So what that looks like is we set up the student's environment, we get them a computer, and the biggest thing we've been emphasizing this year is doing asynchronous Java learning. And what that looks like is the students learn Java by themselves, and we use either W3 Schools or CSA Awesome. So they're all great resources. And the reason why we've done that specifically for our team is because we have a lot of people this year, and we can't really afford to have our veteran people teaching each individual detail like for loops, which is why we've resorted to using W3 Schools. In the past, we've had leads and mentors be teaching like individually each unit, whether that be for loops, classes. But this year we've switched to asynchronous learning, and that's a pretty big change for us. Another huge thing that we do is pair programming. I'm sure you guys know what that is. It's where you program with 2 people instead of just 1. We usually pair with veterans and rookies, but for this year we've really just had rookies programming with other rookies, and we find that works really well. And part of our training is doing a lot of subsystems. And we can't emphasize enough, you need to make subsystems over and over again throughout the season. Rookies will make 2 to 3 subsystems. And what a subsystem is it's just a mechanism on your robot that does or moves something. And that could look like just making wheels spin, making an elevator go up and down, or making a pivot up and down. And you've probably seen the star chart already. We also do something similar, except ours is a lot bigger. We have our onboarding process here, and then we have our Java learning curriculum here. So instead of having certain units, we just require each software student to know basic things. So each concept, so arrays, loops, methods, you know the deal. And then after this, we also have a huge robot section, and what that looks like is we have knowing how to enable the robot, simple things like that, as well as knowing how to PID tune. So if you don't know, on WPILib, they offer a simulation for you to learn how to PID tune, and it's really helpful if you just search up mechanism tuning. We use that a lot to teach our new rookies, our new members, how to PID tune, as that's a huge part of what we do. So a couple of off-season projects that we like to do to enhance rookie retention, because we don't expect the rookies to like just programming Java every day and learning for loops every day. So what we do is we have a couple of projects. So I've listed a couple that we have done in the past. I've already covered making subsystems, but we also do things like 3D simulation, a light show. So we have candles this year. I don't know, it's a new CTRE product. And that's been pretty good fun for rookies and veterans programming the lights. We've also programmed the motors to make music. The DC motors can make music, and that's been really fun. We did that last year with the rookies, and that definitely boosted. So we have all these little projects to get these, and my biggest takeaway from this is just make it simple, make it easy, and have that instant gratification where it works or it doesn't work, and you can easily figure out how to fix it. These 2 things have been added on in recent years. This is more for veterans. We've been working on a state machine. Does anyone here know what a state machine is? All right. But that's been one of our projects. So we vary it between the levels of intensity because, believe it or not, veterans get bored too. So we need to keep them entertained. And we do that with more advanced projects like this, whether that be a state machine, and recently we've been looking into, or throughout the summer, we've looked at GTSAM, and that's been a way of fusing odometry through factor graphs, but I won't cover that in this. So what should you prioritize in the off-season? You've probably seen this from my Medtronic presentation last year, but I can't emphasize enough, you have to learn your language. So whether you're programming in Java or Python, I would say prioritize that over learning how to make a subsystem. So you definitely need to know polymorphism, what that is, before you get into making your subsystem. Another thing we do is Git. So if you don't know what Git is, it's basically a way of managing your code. So think of it as a Google Drive of figuring out how to manage your code. If you don't use that already, you should be. It's the best way to collaborate with multiple people. And another thing I've noted here is you should be prioritizing, if you're a software lead, or if your software team doesn't have a lead, you should still be prioritizing your rookies, because your veterans are already on the team. They probably know what it looks like. But with your rookies, they don't know what software is about, and learning Java in the off-season isn't fun until you get to the season where you're coding a robot. So we like to have our veterans teach other people, engaging with the rookies. This really helps in the season because then you have more rookies to offload projects to get more things done. So software, we have a tracker, which you just saw. We also have a star chart. So you've probably already seen the star chart from controls, but we also have a star chart here. And we've used that to great success, although it's not filled out yet. It's completely empty, as you can see. But we also have a bunch of skills, and it's really helpful to track progress, and it's going to be great for the rookies, even though they haven't seen it yet. So another great thing that we like to do, and you'll notice that a lot of this presentation is just how to get people engaged. And that's a huge part of software, because once you get into the nitty-gritty of software, it's just smooth flowing from there. But what I like all of you guys to do now is what we've done in the season, or in the off-season, is bubble sorting ourselves. So if you don't know what a sorting algorithm is it's a way to sort. If you have like a number of 1, 2, 3, 4, 5, it's not going to be sorted. It's going to be 5, 4, 1, 2 differently, and a sorting algorithm just sorts that. So how we like to keep people engaged in learning about new programming concepts is to sort ourselves. This is something we've done. I'm sure the rookies have done it. Is sorting ourselves via bubble sort. So an example would be, do you want to help?
Sure.
I would like one more person to come up. All right, Ian. So what it kind of looks like is we have all of us around a table, and this really helps with any sub-team. It's not just software. If you have a big team of controls members or fabrication members, this works well too. So what it looks like is, well, I guess you don't have a partner there, but you would turn to the person next to you, so you'd probably turn to the person there that doesn't exist, and I'll turn to you. And what we do is we first ask each other, for example, something very personal, like what's your social security number? And then we sort ourselves based on that. Just kidding. But it's something similar, and it really helps us get to know each other. And these really quirky, nerdy, fun team bonding activities really help to solidify the robotics environment. For example, I would ask him, how many pets do you have?
1.
All right, I have 0. So then what happens in bubble sort is we switch places. And then what happens now,
How many pets do you have? 2.
okay, so they already sorted. So now we're sorted from low to high. So I have 0 pets, he has 1 pet, he has 2. But what happens if both of you two have 2 pets? What happens then? Does anyone know? Next question. So in sorting, there's something called a tiebreaker. So if we have a tie between 2 pets, we then ask, we've done this in the past, how big is your lawn? So between you two.
How big is your lawn? Oh.
We pulled up Google Maps for this one.
You should say it's square yards.
Yeah, 20 square yards. I don't know. Okay, mine is more than 20 square yards.
All right, so then they switch. All right, and now we're sorted again. So we do this, we've done this in the past, and it's worked well. It's great to get people know each other, and you can even expand that to merge sort, insertion sort, whatever sorting method you want. There's also, I don't know, many others. Oh, yeah.
Well, what if you have a larger yard than
Oh, what if? Oh, but we're first sorted by the number of pets. So the first sorting criteria is just the number of pets we have. But then, yeah.
Why don't you use BOGO sort?
BOGO sort? We could do that, but isn't that just random? You just
Yeah.
put everyone in different places and hope for the best.
Oh, you shuffle it until.
Yeah, you just shuffle it until it gets to it. But
Oh.
you could do that with your team. Either way, this is a great way of getting retention. I would do it with all of you guys today, but we don't have enough time, so we're not going to do that. But try it with your own team and see how it goes. It's a great way to keep students engaged and just know that robotics isn't just, or even software isn't just learning Java. Thank you guys. You guys can go back. Oh, that wasn't my that wasn't my question. Oh, sure, you can clap. But.
We're done.
Yeah, we're done. Thank you guys for coming. We learned about sorting methods. Amazing. All right, so version control. I think you've already know what version control is, so I won't talk too deep into it. But make sure you learn Git, because I've seen teams with just one computer where they do all the code, and if that computer dies, at competition, we're left with your own code. So learn Git. If you don't have Git integrated with your team, you should do that. And we can skip this, but yeah, thank you. Another thing that we do is code with me. So what this looks like is we code with other people, and this is really great because it gets people engaged with each other. So we use either Code with Me with IntelliJ or VS Code, and we have students pair up with each other and work on different projects. And now we're going to talk about the build season, which is a lot more planning and how we plan our code. So for kickoff, we do the same thing that most teams do. We brainstorm. We begin brainstorming, and the first thing we begin to do is plan out our subsystems. So this doesn't just look like, oh, hey, what subsystem are we going to have? This is more in-depth than that. We plan out how our autos might look and how we coordinate between subsystems. So I've seen teams do this where they have, for example, if they have an arm linkage, they have each individual motor as a separate subsystem. But what this planning process really looks like is seeing how to abstract those into bigger things that don't necessarily have to be very specific. So an example of this would be, I like to think of Jack in the Box robot. Has anyone seen what the robot looks like from this year? Yeah. So their robot's pretty cool. I know, they won Worlds. And what their robot, how they've organized their code this year is they have this huge arm linkage that has, an elevator that goes up, a wrist, and a pivot. And how most teams would do that would they have a subsystem that's just, a pivot. They'd also have a wrist subsystem. They'd also have an elevator subsystem. However, what this planning process really looks like is turning that into one big subsystem. And that would look like, for example, instead of having all these individual subsystems, it'd be an entire arm subsystem that coordinates everything at once instead of having these individual things that you have to coordinate later on. And another thing that I've seen is software needs to be involved in the design process. If you have your software members off to the side and just coding on their own and not being involved with the CAD sub-team or the designing sub-team, that's missing out on a crucial step because believe it or not, software matters. And it's really important to have that process be involved, or that sub-team being involved in the process. And that's also partially why we kind of failed in 2024, because software wasn't able to communicate their needs to the design team, and we ended up with a pivot subsystem that was uncontrollable from the software side, and we had to end up doing 3 separate PID controllers just for a pivot. And another important thing is just housekeeping matters. So what we like to do before we even begin our code is to update all of our libraries and firmware, because every year WPI releases a new version, right? It's 2026 WPI, 2027 WPI. And a big issue is, do you want to switch? Because you programmed all of your code last year with 2025, but now they're on 2026. So we make that, and somewhere along the season you want to migrate, but it's hard to decide when. And you kind of want to plan that out before you dive into the code, because versioning is a big headache once you get to that. And we like to plan ahead, and we like to think, hey, is Pathfinder going to give an update? And what new features are they going to provide for us that we might want to use? And if we want to use them, when do we want to update our Pathfinder to that new version? And then after that, we like to set up all of our robot scalars before we even get the robot. So we ask CAD for, hey, what's your pivot gear ratio? And we do that also through Sim, which we'll talk about right after this. So 3D Sim. So this is something, who here knows what 3D Sim looks like? Okay, only a few. So what 3D Sim is it's a simulation platform that allows you to visualize what your robot looks like before you even get a physical copy. And it's really nice because you can figure out if you need to add some protections. For example, with this year's robot, it's pretty simple. We just have a ramp and an elevator. But if we had a more complicated robot, you'd have to be figuring out, collisions and other mechanisms interacting with each other. And you can do that through CAD, but we also do it with our software. And that's where software is powerful, because you can test your code with 3D mechanisms before you even get them. And to do that, we use Advantage Scope and MapleSim, and that's been kind of like the standard by now. I know 254, many other teams use them now, and they're really helpful for having students hands-on engage with the software process before you even get the robot. Because during the initial stages of the build season, software doesn't have much to do, right? You're just coding, doing what software does best. I don't know what they do best. But with 3D Sim, it allows you to do and simulate all of these things before you even get the robot. And you don't even need to have a high-fidelity CAD model to do this. If you don't know what Advantage Scope is or all of these tools are, that's okay. You can do a lot of research on your own, and there's lots of great materials online that can help teach you or give you all the information you need. Even in the beginning stages of your build season, just have your CAD send you, hey, what does our elevator look like so far? Just give us a model. And that's what we kind of did in the season. And what that gives us is a pretty decently high-fidelity model to work with. This also gives your sub-team members an extra thing to do. So if you have board software members, simulation is always something you can constantly improve upon. And for example, they could reorientate the 3D models. And another benefit of what this 3D Sim allows you to do is simulate autonomous. So we actually use this quite a lot in the season. And what that looks like is we can run an autonomous program and simulate all of the movements, including collecting coral and elevator movements. You get the idea. So with 3D simulation, first off, it's a very high ceiling. Your simulation can just only get better, and you can add more quality of life improvements. But if you have the simulation, it allows all of your software members to kind of spread the workload and give more things for your students to do. And I would love to talk more about how we implemented this. We'll be releasing all of our code after KCMT, so you can test that for yourself. All right, back to the rest of the build season. So a huge part of what software is just testing and iterating and providing feedback for the rest of the team. So just some basic things that we like to value, and our philosophy is just testing over and over again. So that's part of the reason why our robot was so simple this year, was because we wanted to prioritize software testing over complicated mechanisms, and that's part of also the systems engineering that went on. And the biggest thing that we found was failing fast. So with software, we prefer to test it rather than testing it at the competition. And what that looks like is whether you do that through 3D Sim or testing it with your robot, we like to prioritize testing and failing before it fails in a match. So for example, one thing that we did is ramming our robot into a wall over and over again and over and over again. And what that does for us is that tells us, hey, is our software robust enough, or is our robot robust enough to handle all of these things? And part of software's responsibility is just to help the design process and make things more robust, and testing it and abusing your robot as much as you can. So an example of this would be testing autons. Although safety is important to us, testing these things, the learning experience from there is that we want to be sure that our code won't fail. Sorry. We want to make sure that our robot won't do that in a real competition. And we did that because what we do with testing is just testing, trying to make our robot fail, but seeing if we add extra edge case protections and to make sure that that doesn't happen. And another thing is organizing your code. So over and over again, when I go to artists with other teams, I see teams with all of their code in one big file. And a robot.java that has like 4,000 lines of code, and that's both unhelpful for the people that's helping you, and you probably can't read it. And this goes without, and this is probably a given with most of your teams in software, but make sure to separate and abstract, and try not to have, in our design philosophy is to try not to have more than 500 lines of code per file. And I know robot container might be an exception, but that's generally our philosophy there. And finally, for competitions, we also make a systems checklist. And this typically looks like just testing all of our controller bindings as well as testing overrides. So if you don't know what overrides are, they're basically, if you have some automated function, make sure to have a button to test those overrides. And what overrides allow us to do is to manually perform automated tasks. For example, scoring or aligning to something. Another thing that we've introduced recently is GitHub projects. So this is another way of organizing our code. And it's basically like a Kanban board that tracks every little functionality that you might want for every feature that you might want to implement in the future. And we track this through our to-do, in progress, and then completed. And we do this through issue tracking and pull requests. Another thing that we like to do is use spot lists. I think this is included in Gradle, but with organizing the code, we like to ensure that we're using screaming case for constants, and also ensuring that our indentation is proper, because that makes your code look ugly if you don't have proper indentation. We also really like to use ChatGPT, which is not listed on here. I would actually recommend to not use ChatGPT. And I know it's a prevalent tool, but it actually is not as useful as just looking at the documentation yourself. So just be warned, this is just something, try your best not to use ChatGPT or Claude AI or any other models like that, because they tend to be inaccurate, even though they might spurt out something that seems useful. All right, I'm going to open it up to questions. I know it's almost time for a lot of people to leave, but if you have any questions about how we do our software.
Do you do any, storyboarding or pseudocode?
So we actually don't do pseudocode. That's part of just because we have our simulation now, so we can just directly test it. We do often go to the whiteboard for autos specifically. So for autos, what we like to do is map out our commands. So we like to say, hey, we're driving or precise lining at this point, we're aligning to the reef, and then what are we doing in parallel or in sequence to that? But we don't do pseudocode for most of our functionalities.
Okay. How much commenting do you put in your code?
So that's something that we don't really do well at, but we don't really do too much commenting with most of our code, because mainly with our subsystems, because they're all just like the same thing over and over again.
Right.
But with a lot of our things that other people might have done that was like a quick fix, like a workaround, for example, like some crazy math that prevented the robot from turning. We might add some comments saying like, hey, don't remove this because it'll break everything. And I know most of the people here aren't software, so it's okay if you don't have any questions, but.
Do you have regulations or like rules put in place for like certain variable naming, constant naming, or commit message naming?
For commit messages, we try to be as descriptive as possible. And I know we've kind of relaxed that as the season goes on, because we need to make fast changes. And at competitions, we like to say like before qual's number and what change we made there. So at competition, typically commits get more detailed, but in the off season or during the build season when we're just at our headquarters and just programming, we don't really do that.
Okay.
So, and then as to variables and constants, we actually don't do like the K. So I know a lot of people do K, like wheel radius or like constants. We don't do that anymore. and we like to use camel case and, screaming case. It's time to go. Oh, no, man. Okay, this is interactive, but we're not going to get to it today because we're running short on time. But yeah, if you have any other questions, we're going to release our code after KCMT. So if you want to look at our code for our 2025 season robot that we programmed this year, including our 3D sim, that will be released on our GitHub soon.